All right, so I'm hoping you all went to John Hughes. Can everybody hear me? Yes. Okay. I'm hoping you all went to John Hughes' talk yesterday, and if you didn't, go watch it on YouTube when it comes out. But he's talking about this with the evaluation. So let's just review. First of all, who here has used QuickCheck before? Okay, John, I know you've used it before. You invented it. If you hadn't, I'd be worried. So we'll just give a quick review in case John forgets something. So basically the idea is that instead of writing tests as you would in unit tests, we're going to generate them. We're going to express invariance through general properties versus specific examples. We're going to run lots of tests, and we're going to hopefully find all the weird error conditions before our customers do. And then when we find the weird error conditions, we're going to remove all the extraneous cruft so that we only see the things that are actually causing the errors, not the other random things that happen to happen. So that's the 30-second introduction to QuickCheck. I don't know, did anybody time me? Was it actually 30 seconds? Oh. What? 25-second introduction, thank you. The fractals have no purpose besides being pretty, by the way. I just wanted to give you all something to look at besides my... It's my equivalent of a cat picture, yes. But it's got, math. So when we test a system with state, we want to model the system. And we're going to basically create an event stream to run through the system. And then we're just going to validate that what we think that our model reflects what's really happening. So what we need is a model airplane, or a model system, not a model airplane, but I don't know how to create a picture of a model system, so you all get a P-51 Mustang. All right. So we could create our model in Erlang, and sometimes that's a great thing, a way to do it, but sometimes it's awkward. And sometimes you sort of end up with this case of your model ends up being just a clone of your code, which is kind of pointless, because then basically you end up saying that your code is, you end up with a big tautology, where you're testing something, you're saying, okay, this works like itself, and that's often not particularly a useful way to do things for the obvious reason that, you're not going to find bugs if you're... So we want to use an external model. The problem is writing an external model sometimes is a pain in the neck. So we're going to say what we might make this easier. And there are various ways we could do this. We could use an existing external program if you want to test if if you're creating JSON or YAML or XML or whatever. You could use a program to validate it in JavaScript or PHP or Python or whatever. And you could say, okay, this input passed through this JSON encoder should always form valid JSON, and we're going to use this Python program to test that it is in fact valid JSON. That's a great solution. That works. But it only works in the case of like JSON, where JSON encoders and validators are fairly well standard. If you wanted to say, is this document a valid JSON, you could go to json.org and you could find a piece of software in any language you can imagine, and probably a few you couldn't, that will parse and tell you whether a JSON is valid. JavaScript and Python would be good choices. But what if your system is not something as simple as, is this a valid JSON? So you need to create a model. And I have this idea that we could use Prolog to represent certain kinds of models more effectively. This won't work for everything, of course, but for the things that it will work with. Now, I first heard about Prolog when I was in university. They had a course on it that my roommate took. I didn't. Well, my roommate took it. And then I kind of didn't think about Prolog for 20 years. I kind of knew it existed in sort of the general way you know something exists without thinking about it. But I hadn't thought about it. And then a couple years ago, I started, a book appeared on my box. This book. It was written by some guy who I think is sitting over there. And honestly, if you haven't read this book, you should read it. If one of the 7 languages in this book doesn't make you go, unless of course you already know all 7, I guess, doesn't make you sit up and go, wow, that's really cool, you're in the wrong line of work. If you can't find something cool in one of these 7, seriously, go do something else. But for me, it was Prolog. There was a Sudoku solver. I won't show you the code for it, but basically it's like 20 lines of code or something to solve a Sudoku puzzle. And you're just looking at it and going, okay, that's nice. I see this. All right, he explains there's the problem, but where's the code? There is no code. So that was kind of an inspiration. I started looking into Prolog some more. So what is Prolog? Prolog is programming with logic. And what do I mean? And there are lots of programs, it's been around for a long time, there's lots of different versions of Prolog. There's SWI Prolog, there's GNU Prolog, there's Sixtus, which is commercial, there's Eclipse, there's XSB, there's YAP, which stands for Yet Another Prolog, and their website looks like it hasn't been updated since the 90s. If you want to run it on a 68K, they're good. And for this talk, the one is ERLOG, which was invented by Robert Verding and basically runs in a process on the Erlang virtual machine. It's not necessarily as complete as SWI or some of the others, but it has the advantage that for small things at least, you can run it inside the beam, just in a process and interact with it, or inside your own process, which creates a very low impedance between your existing code and Prolog. If you want to do something really big with Prolog, I would suggest you probably want to grab something like SWI or Sixtus or something and set up a port, but that's beyond the scope of this talk. So a little history of Prolog. It was invented in the early 70s. It's often used in AI. It was used, Joe over there and Robert, you guys used it to develop Erlang. And most recently, if you saw Jeopardy, apparently the Watson computer that won at Jeopardy, not exclusively, but apparently in part was developed in Prolog. So, you know, what is Watson? That's not actually relevant to anything, but it's kind of cool. All right, so ERLOG. Doesn't have a home page, but this is the GitHub page, Robert's repo. And it has some useful features. It is an approximately an ISO Prolog. It's not, I don't think, completely complete, but it's got most of the stuff in it. It runs in an Erlang process. And you can actually tell it to talk to an ETS table, so you can put data in ETS and read it out and do other useful things, which is sometimes useful. And, of course, it understands Erlang data. So let's look at some basic Prolog structure. Who here has written Prolog before? Oh, OK. That was not what I expected. All right, you all can go to sleep for the next 4 slides. This is the problem with this type of talk. You know, because you have to make a guess, and inevitably you're going to guess wrong. Because if I'd skipped the next 6 slides and I put to ask that question, 2 hands, Bruce and Joe's hand would have gone up, and all right, and Robert's, and nobody else. So you all can. Okay, so we have a Prolog program is created with some facts, and rules. So simple, we have some facts. We have a model with a key and a value that doesn't really do anything. And then here we have a small non-directed graph. We have an edge from A to B and an edge from B to C. And these are atoms just like in Erlang. Erlang atoms are a direct steal from Prolog atoms, I've been informed. Joe, is that right? So you have some simple facts here. There's no computation here. It's just you're stating some facts, that there is an edge between A and B and between here and an edge there. All right. So now we can state that 2 things are connected. And notice, again, it's a capital letter, like as a variable as in Erlang. A is connected to B is connected to C. And you can say A is connected to B if there's an edge between A and B, or there's an edge between B and A. So these are actually, I didn't draw an arrow, but these are actually directed links. But we're treating them as undirected here. So that you can say that, you know, we don't care which way, in this case, we don't care which way things go. We're just gonna connect them up, and we'll write the code so that it can go either way. So again, here we have some sort of a longer example where we can just say we're going to create a bunch of facts. We're going to create this rule that how A and B are connected. And then you can ask the interpreter, you know, is connected A to X, and it'll just tell you all the things that A is connected to, B and C, and if it's more, you can just keep hitting semicolon, and it'll keep repeating them. Or if you're using it internally, programmatically, there's just a function you call, and just spits out the next one, so you get the whole list. Although be careful about asking for the whole list, because not in this case, but it is possible to generate an infinite list, and then you'll be there for a while waiting for it until you realize you created an infinite list and hit Control-C a bunch of times. I've done that. Don't do that. You could also generate infinite lists there, but you can still hit Control. You can still. What? You can create it. Yes. You can print it out too if you're not careful. In any case, kill-9 can be your friend. You can also create a lazy list in Prolog. It's just, in this case, I hadn't. All right, so then we can also, but it also, this is nice, unlike Erlang, it goes both ways. So instead of, in addition to saying, is A connected to X, I can also say, is X connected to F? And then I'll tell you everything. So it's completely symmetrical, which is kind of neat. It doesn't always, to be pointed out, it's not always equally efficient to go both ways, to do it either way, but syntactically and semantically it works. So the other thing is we can define something recursively. We can say, is it fitting on my ear right, that there's a path from A to B, and again, the path I highlighted here in this purplish color is an output, or potentially is an output. If you can travel from, do this, from A to B via some internal variables. And then here, basically, you can say, again, we have two clauses as in Erlang. If it's valid if A is connected to B, or A is connected to C, such that C is not B, and that you can travel then from C to B, and it'll find any and all valid paths, and it will search through, and it might if there's 20 steps between A and B, it might go through, back up, and keep trying again. So you do have to be vaguely careful, because this kind of, depending on what you're doing, this can have weird runtime performances. But for most of the things I'm looking at, if the data sizes are pretty small, so it isn't really an issue. If you have 10,000 edges in your node, this might blow up. But if you have 20, you're probably okay. But yeah, so basically you can just and again and this is all reversible, so you can also say or in addition to being reversible, you can also say if you have a node A and a node B and a path, you can pass that in and it'll return true or false if the path is a valid path from A to B. So if you want to validate, if you have what you think is a valid, or what might be a valid path, you can use this code to say, is this path valid? Or if you have two endpoints, you can also say, what are the valid paths between these? And you can even do things like say, what are all the valid paths that start at A? And where do they end up? Again, you may end up with a lot of data. So, and you'd run it like this. Path A comma F, path, and it'll return a list that is the path from A to F, if there is one. Or it'll return a failure if it can't find a path. So far we've been showing basically all with static data. We've created a dictionary with some facts, and we're just asking questions. But you can also change the facts in a Prolog system using assert A and assert Z, which just adds the beginning or end appropriately, and retract, which will remove a fact from the system. And this is very useful for stateful systems. So what kinds of problems can this solve? Because obviously it's not going to solve every possible problem. So with a state, you can use a state model. Anything that involves like an algebra, sets, graphs, things like that. Grammars, you can do a lot of stuff with context-free grammars in Prolog that I'm not going to get into today, but they're interesting. A finite state machine can be easily modeled this way. So when I started playing with all this stuff some months ago, I started with something I'd done before, which was a last value cache. So I wanted a system where basically you could have a key value store, and it would just save whatever the last value you stuck in as a key. Oops. So I wanted to create a model in Prolog to do this. And I will be the first to admit, I'm not a great Prolog programmer. I'm still learning. But part of the point of this is that I've discovered that you don't have to be a great Prolog programmer to get some basic stuff done and get useful results. You don't have to be the Prolog Kung Fu master to do this. So I started with this. This is the model. Basically, I said add to model key value, where I retract an existing model, any existing models that have that key, and then assert the new key and value. Okay, so then how do we run ERLOG in our test? So there are two ways you can run ERLOG. One is you can run it as a gen server, or you can run it in the process. I'm running it as a gen server here. So basically, you do ERLOG start link. It returns a PID. Then you do ERLOG consult, which basically just reads in the file, which is the previous slide. And when you're done, you do ERLOG halt, and there obviously will be some. If you don't, you should do something useful in between lines 3 and 4 here. Otherwise, you have a pretty boring program. It's like start, stop. Okay, good, we're done. So here's what I did. So basically, what we did was I just created, using QuickCheck, a series of gets and sets with a set value of number of keys. And then the values were all integers, just for simplicity's sake. And again, this code is sort of the hello world of this exercise. This was not meant to be a real system so much as just saying, all right, I know how to do this in Erlang. Can I figure out how to do it in Prolog to make sure that I'm vaguely on the right track? So, but you have two operations, set and get. So here's set. And again, we just pass ERLOG in, key and value. And then basically do an ERLOG prove, which is the ERLOG API call. Add to model, key value, and this is just calls that function. And then we do succeed true, anything else false. And then the false will cause the test to fail. Now add to model should always work. Basically, we're just asserting that this is the new value for a given key is X. If for some reason that doesn't work, we want to fail the test right away. Now, a more interesting thing is if we want to say, what is the current value of a key? And this is the get operation. So here, we basically use this funky tuple-looking thing here, which is just an atom inside curly braces, or atom inside a tuple, to say this is a variable in Prolog. This is basically just Prolog turned into an AS. One line of Prolog turned into an AST, as was the previous thing. You could also actually write out the Prolog, but this is a little easier and saves you some optimization. So basically, one of two things is going to happen. Either we're going to get back succeed Y value, again, the variables there match up, in which case we return OK value. Or if this value is not in the model, we don't, this has not been added to Prolog yet, you're going to get a not, it'll just return not found. Because of course that might be valid. You might ask the cache, what is the current value of X, and it might not know. I'm not showing all the QuickCheck code if you here, because that's sort of, I just want to show the Prolog. If anybody has any questions, please stick your hand up, by the way. So, more fractals. So again, the other thing we can do is, I mentioned earlier, is algebra. I've become a big fan of using algebra and of sort of thinking programming in terms of algebra. You can do graphs, trees, CRDTs. I mean, these are rather complicated, but you can do them. I'm not going to show you how today, but I imagine you. So what we're going to look at is a partially ordered set. You've all seen a partially ordered set before. If you've ever looked at a git commit history, it's a partially ordered set. They show up all over the place. A vector clock is also a partially ordered set. So then the question is, what are the operations you might want to do on a partially ordered set? So you might want to know, is there a path from A to B? This is similar to what we did before. It just only goes in one direction. So here you can see I have highlighted the path from here to there. or a path. There, of course, if you look between here and there are many possible paths. You can go this way, you can go that way, or this way, or you get the picture. You can also say, can you travel? And again, this is sort of the same code we saw earlier, vaguely modified so that you can only go one direction. More interestingly, you can say, is this a child node? So this node has no children. You know, it's a leaf node of the tree. Well, if it was a tree, you'd call it a leaf. It's not a tree. And it's just here, you just do this \+, which is a not operation. And you say basically that there's not an edge from A to anything. And that's, you know, definition of a child. You can say, are these two nodes siblings? You can say basically, if there's a path from some node C to A and from C to B, but not a path between them, then they're siblings. Fairly straightforward, fairly obvious. Ancestor and dependent and descendant are, again, they're actually the same function, just reversed. You could make that one function if you felt like it, or one clause. I made it. I kind of think you should make it two, just for value of being explicit, so that you call the one that you actually care about. It does the same thing internally. It just to make your code easier to read. Okay. How am I doing on time? What?
Copious amounts.
Copious amounts. What? No, it's fine. I just this went faster than I thought it would. No. What?
Few questions.
Yeah. Okay. So how do we test with it? All right. So, and I'm not going to show you the test code because I haven't really written it. It's sort of an action. Basically, we're just going to create an initial state. We're going to create events that'll just on any of the nodes in the system that might be in a vector clock, and then check on it that it did the right thing. So, okay, so now basically Q&A, because I guess I'm not very good at estimating talk time. Any questions? Dead silence. Crickets. Somebody.
Can you get into some of the applications that you like? What's a case for this that you worked on?
So the cases I've just been playing. You know, this is sort of it's still in the trial. You know, I've been playing with it mode. I think if I were to try to do something with partially loaded, anything that was algebraic would seem to work. Anything involved with grammar, I think would work well. I didn't show any of that. I don't have any slides for that, but you can also do some cool things with grammars where you basically just do a context-free grammar. It's very nice syntax in Prolog, and it'll just spit it out. So that's sort of the obvious cases. The full list of languages were, Bruce, tell me if I forget one, but Ruby, IO, Prolog, Scala, Clojure, Erlang, Haskell. Not in that. I got the order wrong. I got the order wrong. It wasn't. That's not the right the order they're actually in exactly. But he's got a whole series. They've got 7 more languages. They've got 7 concurrency models, of which there's a talk coming up next in this room. So just stay put. You'll hear it. 7 web frameworks, databases, and I think I think so. What? Yeah. This has been an unpaid promotion. They're good books. The real idea here was that I'm just sort of playing with ideas for how can I express the ideas of my code in a more declarative way than I might have done previously. So it's not a hugely developed concept. It's sort of experimental, and I'm just something I'm playing with. So, Bruce.
Just a comment. I think that most of the people that read the Prolog chapter of the initial book said that the hardest part for them dealing with Prolog was getting in and out of Prolog to see something useful. And this is a great example of the integration with ERLOG.
Right.
That makes.
Yeah. One problem or one issue that many Prolog implementations have is they're in and of themselves very powerful, but they don't necessarily integrate easily with other languages. There are versions that do. Robert's ERLOG, integrates very nicely with Erlang, and I haven't tried it, but I would imagine you could integrate it very nicely with LFE or Elixir or any of the other Erlang languages. Because again, it's just an Erlang process and stuff. But yeah.
Sorry, really just to back that up. So I played with Prolog many years ago and kind of gave up on it because it was brilliant at solving that very specific class of problem that it was designed for. But when you try to step out into the more general purpose code that every project needs somewhere down the road, I just found it frustrating.
Right.
But recently I've come back to it in the form of core data within closure, which is a very similar.
Core logic, yeah.
CoreLogic, sorry, it's CoreLogic within closure, where you can kind of play in that Prolog world when you're solving a Prolog style problem,
Right.
but then move out into a much more general purpose.
Right. I mean, CoreLogic is based on the Kanrem system. I actually found an Erlang implementation of Kanrem. I created a GitHub repo. It was like buried in a repo with like JavaScript and 4 other versions. I created a repo for it. It's on GitHub. It's called Erl Kanrem. I mean, you can find it in my user account. I do not guarantee it works. It passes the unit tests that it came with, and it passes Dialyzer, but I've not actually used it for anything beyond that. If any of you would like to play with it and let me know, I'd be curious. But the real place I see Prolog, especially ERLOG, being valuable is it is the 5% of the pie, where you have 95% of your code for whatever your app is written in Erlang or Elixir, and then the 5% that has to do something rules-based or logic-based or parsing-based. You write that in Prolog so that you can then take advantage of that power. I would think, Robert, correct me if I'm wrong, you wouldn't want to use huge data sets with ERLOG, right?
Not now, no. Not currently.
I mean,
The way database implemented data.
if your database is less than 100 facts or so, it probably will work pretty well. If you wanted to do 100,000 facts or 1 million facts in your database, SWI or one of the other Prologs would work. In theory, it should be possible to create like a port between SWI and Erlang. And they have C extensions and web extensions that you could do other interfacey things with. I do not know that anybody has done well, they have that's not true. They have a web thing, so you could, talk to it via REST. You should be able to create a port for Erlang to talk to it, but I don't think anybody has done it yet, so.
If you want to do big sets of facts and rules, there best way to do that.
Right. Yeah, you use an ETS table. And I've actually been also adding QuickCheck tests to ERLOG over the last few weeks so that they're trying to get in there. There are, I don't know, 20 or 30 tests, 20 or 30 properties now that don't test everything, and I'm sort of slowly adding them as I have time. I try to add a couple of, try to add 1 or 2 a week or something, so that they will be there. And then hopefully if ERLOG gets more use cases, we can improve the performance of it to the point where you could handle bigger data. But my experience with Prolog is, especially for a lot of this stuff, that even with fairly small data, you can do some cool stuff. There's a lot of applications that I think with 100 facts in Prolog, you could do very clever stuff. And then, again, handle the 95% of the application using other Erlang tools for, build your web API with Web Machine or Cowboy, and then use ERLOG to do some piece of it that makes sense. Bruce?
So one of the things that we found with the seven more languages book, we introduced the mini Kanrem, which CoreLogic is based on, was that we found 2 kinds of users. One kind of user said, this is not functional programming anymore. This is functional programming plus logic programming, and they were woven together in a way that we didn't recognize this thing. And one class of users said, this
I didn't think it was too hard. I mean, I think I peppered Robert with a bunch of questions via instant messenger, which he was very kind to answer. But once I got the syntax down, I found it was fairly straightforward. I found the, oops, sorry. I don't know where my mouse is. I found this book, which I actually have in my bag, very useful, though also the website learnprolognow.org. Not nearly as exciting as Learn You Some Erlang, or not nearly as whimsical, but still very good, these two resources. This is more of an advanced book that I'm actually planning on ordering any day now. Were very useful, and I think part of it is you just got to get, I would not start with ERLOG, start with SWI, and get one of these two books and just sort of work through all the exercises. And then don't be afraid to go on the IRC Prolog channel or on Stack Overflow and ask questions. Joe?
Prolog is sort of niched into constraint logic programming these days. And that got almost 100% dominance in things like planning aircraft schedules and planning rotas for hospitals. So there's some very niche companies that use constraint logic programming. There's an actual mini-zinc, which is where all the constraint programmers hang out. Mini-zinc? Mini-zinc, yeah. I mean, so there's at least 500 people in the world using it. And that is the front end, because it niched out. The problem with Prolog, it couldn't solve integer constraints and packing problems and things like that. So it niched into constraint logic programming, which is the world's fastest constraint logic code.
Yeah, I mean, the problem with some of the constraint logic programming is, depending on what you...
We're actually using it to build compilers with.
I mean, another idea I had with ERLOG, I haven't really worked with it, is you could, or with another Prolog, is you could, use it with rebar as part of your build process to do some sort of static analysis on your code base. Get Erlang to spit out an AST. Sure, the Erlang compiler can do that, right? There's some flag or other that'll spit out the AST. What?
It does,
Yeah,
yes.
I was pretty sure it did. I just didn't, you can look up what the flag is, because I honestly couldn't tell you. And then, look at code styling or something, although honestly you're probably better off just using Wrangler for that. Right. Or, the other thing you could say is, if you want to know is, if you want to say, you could say in code, I've not actually done this, this function should be a pure function, sort of in the Haskell sense, and then have part of your compile cycle be, for any function so marked, analyze the AST and figure out if it's impure, break the build. I haven't done that. If anybody does do that, let me know. It'd be cool. So there's a lot of places like that, parsing, analyzing, stuff like that would be very useful. The other app I had was, my wife and I were planning an app to do recipe sharing on Facebook. Because if you read my wife's Facebook page, it's like her and her friends discussing what they're cooking for dinner half the time. And the problem is, we had this idea for an app where if you said, well, I want to plan a dinner party for 20 people, and I have, 2 people to help, and, this many, I want to make these recipes, and I have this many, 4 burners and an oven or something, it would go through and tell you that, oh, yes, you could, here's a schedule you could use to get done, or no, that's impossible. No, you cannot cook a meal for 100 people on a 1-burner hot plate using nothing but a wooden spoon in a small pot. I'm sorry, that's not possible. Or if you did, I'd be very impressed. So, all right, that's all I got. If there's no more questions. So, thank you, Garrett. Thank you, everybody, for coming.